Bismillahirrahmanirrahim. Today I'd like to talk about rationalizing the denominator. The first thing we have to understand is, what does it even mean to say to rationalize a denominator? Well, when we're dealing with radical expressions or radical numbers, such as 2 over square root of 5, it is not considered proper mathematical manners, so to speak, to have radicals in the denominator. Now you would say, well, I didn't know that mathematicians had manners. Well, they do. Regardless, it's considered to be not the simplest form of this expression. In other words, if you wanted to simplify this expression, we would be obliged to get rid of this radical sign from the denominator. Now, if you recall, any square root that is not a nice and neat square root like 16, the square root of 16 being 4, any square root that is not nice and neat like this, the square root of 20, this would be an irrational number. Therefore, if there are square roots like this, square root of 5 in the denominator, that means we have irrational numbers in the denominator. And that is considered not desirable, not the simplest form of this number or this expression. So the process of getting rid of this irrational number or making the denominator into a rational number, this process is called rationalizing the denominator. So again, if you have a number like this with an irrational number that is square root of 5 in the denominator, that's considered to be not the simplest form of this number. And the idea is to change this number into a different form without changing its value so that there's no square roots in the denominator. And that process is called rationalizing the denominator. Broadly speaking, we'll have two types of problems. The first one will be like this, 2 over square root of 5, and our objective will be to get rid of the square root from the denominator. A second type of problem will be something like this, 3 over 2 plus square root of 5. We'll have a binomial in the denominator. That is, the denominator will be two terms like this. So these will be two types of problems that we will encounter. So here again is 2 over square root of 5. Now how do we get rid of the square root of 5? Now questions like these are reasonably easy. All you do is you take the denominator and multiply the numerator and the denominator by the same number like this. The reason for this is when you simplify this, the numerator here will become 2 times this, or 2 times the square root of 5, and the denominator will become 5 times the square root of 5 like this. And we know that 5 times square root of 5 is simply 5. The reason for this is, you recall, square root of x times square root of x, for example, is square root of x squared, because you can bring these under the same umbrella, and square root of x squared is simply x like this. So multiplying the numerator and denominator by the same number, that is the denominator, will basically get rid of the square root from the denominator, because square root of 5 times square root of 5 is just 5. And the numerator here will just be 2 square root of 5. Let's do another example. Let's say we had 3 over square root of 7. Again, similarly, all we do here is multiply the numerator and denominator by square root of 7 like this. And the numerator will become 3 times the square root of 7, and the denominator will become square root of 7 times square root of 7, or simply 7 like this. Not all questions will be as simple, of course, but let's try some trickier ones. So here's square root of 6 over square root of 27. Well, you can multiply the numerator and denominator by 27 over here like this. That would be okay to do. But if you recognize that you can simplify 27 by doing prime factorization, this is 3 times 9, 3 times 9 is 27, and 9 is a perfect square. It makes it a little bit easier. So you can rewrite this as square root of 6 over, now you can bring the 9 out as a 3 times square root of 3 like this. Now you see, all you have to do is multiply the numerator and denominator by square root of 3 like this. It's much easier to multiply by square root of 3 than to multiply by square root of 27. Then we simplify this. The numerator will become square root of 6 times square root of 3, and the denominator will become 3, which is this 3 over here, times 3. Because square root of 3 times square root of 3 is just 3. But we're not done yet, because we have to simplify this further. Now we can simplify the numerator by bringing this 6 and 3 together. This becomes 6 times 3. This is because we learned this rule before. Square root of a times square root of b equals square root of ab, and vice versa. So we brought the 6 and 3 together like this. And the denominator becomes 3 times 3 is 9. Well, we're still not done. 6 times 3 is 18 over 9. But then you can simplify 18. So square root of 18 can be simplified because 9 is a perfect square. So this becomes 3 times the square root of 2 over 9. And finally, you can see that 3 goes in there 1 time, 3 goes in there 3 times. So this will become square root of 2 over 3. And that would be the final answer. Again, what we did here was first we simplified the denominator. We did prime factorization of 27, and then this fraction became square root of 6 over 3 times square root of 3. And then we rationalized the denominator by multiplying the numerator and denominator by square root of 3. We combined the radicals in the numerator, square root of 6 times square root of 3 over 3 times 3. Now this got rid of the square root from the denominator. Then we simplified this, and we were still not done because the square root of 18 could be simplified by prime factorization of 18. So square root of 18 became 3 times square root of 2, and finally we simplified this fraction and we had square root of 2 over 3 as the final answer. The second type of question, if you recall, was something like this: 2 over 3 plus square root of 5. In this case, we have like a binomial in the denominator. Now you can't simply multiply the numerator and denominator by square root of 5 like this, because that's not going to work. Because then we would have to distribute the square root of 5 into 3 and square root of 5 over here, and we would still be stuck with square roots in the denominator. So in cases like this, you can't simply multiply the numerator and denominator by square root of 5. See, what you have to do is you have to multiply the numerator and denominator by 3 minus square root of 5. 3 minus square root of 5 is called the conjugate of 3 plus square root of 5. In other words, if you have 3 plus square root of 5, it has a counterpart. In other words, 3 plus square root of 5 is one of a pair of numbers, the other number being 3 minus square root of 5. These two are called conjugate pairs. Another example would be if you have 2 plus square root of 7, the conjugate pair here would be 2 minus square root of 7. The conjugate of 2 plus square root of 7 is 2 minus square root of 7. Now, if you had 3 square root of 5 minus 4, the conjugate of 3 square root of 5 minus 4 would be 3 square root of 5 plus 4. If you ever find 3 square root of 5 minus 4 in the denominator and you wanted to get rid of the square root over here, you would multiply the denominator and numerator by the conjugate of this number over here. And the conjugate of 3 square root of 5 minus 4 is 3 square root of 5 plus 4. Now, really, a conjugate is basically the following. The conjugate of a plus b is a minus b. Now, we've learned from before that if you multiply a plus b times a minus b, you get a squared minus b squared. If you recall, there were 3 special circumstances when we were multiplying binomials. You had a plus b squared, and this was a squared plus 2ab plus b squared. And the second special case was a minus b squared, and this was a squared minus 2ab plus b squared. And the third special case, which is of particular importance to us over here, is this: a plus b and its conjugate a minus b. And this became a squared minus b squared. And this is what we use over here, basically as a trick to get rid of the square root from the denominator. Because in the numerator, you'll have 2 times 3 minus square root of 5. And the denominator will become a squared, in this case a is 3, minus b squared, in this case b is 5, like this. Now you must remember these 3 special cases of multiplying binomials. Now, if you didn't know that, you would just FOIL this. Watch. 3 plus square root of 5 times 3 minus square root of 5. Now, if you FOIL this, you get first, which is 3 times 3, that's 9. And then you do the outer with 3 times negative square root of 5, which is minus 3 square root of 5. And then you would do the inner, which is over here, plus 3 square root of 5. And then you would do the last, which is square root of 5 minus square root of 5, and that is just simply 5. And then you would see that these are opposite and they cancel each other out. That becomes 9 minus 5, which is what we're going to get over here. Now, simplifying this, I would just keep the 2 over here for now. 2 times 3 square root of 5 like this. And the denominator becomes 3 squared is 9 minus square root of 5 squared is just 5. Now, I don't know how many times I say this to students. We have square root of 5 and squared. Now, what is this? And then they're puzzled. There's no reason to puzzle. When you take a square root and you square it, it's just 5 like this. So square root of 5 squared is simply 5. You have 2 times 3 minus square root of 5 over 4. Now you can see again, we can simplify this further. 2 goes in there 1 time and 2 goes in there 2 times. So our final answer will be 3 minus square root of 5 over 2. And as you can see, we have rationalized the denominator. There's no more square roots in the denominator. As a review, I suggested to you that there are 2 types of problems. The first is like this, 3 over square root of 5. In cases like this, you simply multiply the numerator and the denominator by whatever the square root is in the denominator, like this. When you're doing this, you're not changing the number because essentially you're multiplying by 1. The second type of problem was something like this. You have 2 over 3 plus square root of 5. Now here you have a binomial, so to speak, a 2-term denominator. In this case, in order to get rid of the square root, in order to rationalize the denominator, you would have to multiply the numerator and the denominator by the conjugate of this over here. The conjugate of 3 plus square root of 5 is 3 minus square root of 5. To finish off here, I'd like to do another example of the second type of problem. Let's say you had this problem, 3 over 2 minus square root of 5. In order to rationalize the denominator here, you would have to multiply the numerator and the denominator by the conjugate, which is 2 plus square root of 5 like this. The numerator will be 3 times the quantity 2 plus square root of 5. And the denominator would be a squared minus b squared like this. In this case, it would be 2 squared minus b, in this case, is square root of 5 squared. Now we have 3 times the quantity 2 plus square root of 5 over 2 squared is 4 minus square root of 5 squared is 5 like this. So this is 3 times 2 plus square root of 5 over negative 1. Now this you can rewrite as negative 3 times 2 plus square root of 5 like this, because the negative can just go in the numerator like that. And then you can distribute the negative 3, and the final answer will be negative 6 minus 3 times the square root of 5. Till next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.